only five will be joined in our Google. So, good afternoon, one and all present here. My name is Abhisha, Assistant Professor in Mechanical Engineering Department in Parul University. We are gathered here for learning and understanding the promising topic on fundamental approaches of modeling and stimulation of for advanced manufacturing processes. We will gain a deep knowledge on how to formulate our approaches for modeling and stimulation of AM processes. Now, I would like to introduce our speaker, Dr. P.B. Taylor, sir. Sir had completed his PhD in mechanical engineering from IIT Bombay. His MTech is from IIT Kanpur in mechanical engineering and Bachelor's of Engineering in production engineering from BVM Vallabh Vidyanagar Anand. He had guided 23 PG students. He has 24 plus years of academic and 3 years of industrial experience. He had an Indian patent in his name. He is a member of ISTE, that is Indian Society for Education, and Institution of Engineers India, FIE. He had delivered 2 expert lectures. He had 34 research papers published and 2 textbooks as the co-authors. He was awarded from the President of India for President Scott in 1988. He is working as a professor from 3 years in Ali College, Morbi. Now, I would like to request sir to please start the session. Over to you, sir. Sir, you can start the session now.
Okay, thank you very much, Professor Ravi, for giving my nice introduction. Okay, whenever I am not audible, please tell me, because from here I am not able to hear to your end. Okay,
Sure, sir. Sure, sir. Sure, sir.
thank you. So, uh, good afternoon to everybody, and today's our topic is fundamental approaches of modeling and simulation for advanced manufacturing processes. So, first, I would like to thank to Parole Institute of Technology, specifically Department of Mechanical Engineering and Automobile, as well as the head of the department, Professor Snehal Trivedi, and Professor Abhi for taking all kind of the pain for coordinating this talk. And I also would like to thank to all the audience for sparing their time and showing the interest to take a part and accepting this uh, discussion. I also would like to thank uh, my all the researchers and academicians whose references at present in our discussion I am going to use. So with this note, I start my formal presentation. This is just basics. Already introduction has been given. Nice introduction has been given by the Professor Abhi. So I just skip this slide. Now for this, our today's discussion flow will be like this. First, we will try to understand some basic concept of this term, what we have in our title. After that, through certain specific kind of the cases belongs to the advanced manufacturing process, we will learn what kind of the different approaches can be adopted for the modeling and simulation for processes, or you may extend it for other applications also. And at last, I will wind up my talk with my remarks and future scope, which can be belongs to this domain. So, very first is that because I know the audience is, I think, from the third semester to the PG level, as well as some of the faculties are also there who are pursuing here PhD. So, I would like to start with very basic certain terminologies. So our lower level student can understand it properly, and later on we will slowly move for or uplift our level of discussion, so other researchers and higher level student can also enjoy the talk. So very first thing is that in our title we say that advanced manufacturing processes. So let us try to understand that first. What is advanced manufacturing processes? So in this, there are the two basic terms, that is the advanced, second is the manufacturing. So initially, the meaning of or the context or what we understood when we speak this particular word manufacturing, that also evolve and continuously changes, and that I would like to put by these 3 points. At very earlier stage, the meaning of manufacturing we understood in the context of that we made by the hand. Whatever we made by the hand, that is the manufacturing, and this word is belongs to the Latin word that is manufactus. Later on stage, as we grow, as we come up with this civilization, we extend the meaning of this manufacturing in the sense that whatever we convert from the raw material to the finished part or finished product through a various machines, equipment, or anything else, maybe tools, etc., that we cover or that we understood as manufacturing. Still further higher stage, later on, from last few decades, we again extended that meaning in the sense that when we talk about the manufacturing, we incorporate the concept of value addition also. And value addition means, I mean to say, we consider the all kind of the activity which we do with through the equipment, tools, or anything else for completing the product, right from beginning of the raw material, right from the concept. That plus we also incorporate the economic aspects. So when we put this all into one single umbrella, that we now call as manufacturing. So I think uh, at present, what we take the sense, that sense is the last what I have told, that is the with the value addition. Now similar trend we can see in the classification also. You can see that also changes. The criteria for the classification is also changes for the manufacturing. Initially, we just classify in this manner, that is the conventional method and non-conventional method, or traditional and non-traditional method. I think all of you are knowing this term, so I am not explaining that. Later on, based on the method what we use, based on that we have started to classify, and we have changed the criteria for the classification of manufacturing, like primary manufacturing processes, secondary manufacturing processes, tertiary manufacturing processes, fabrication, and finishing. After that, again, compared to certain older manufacturing process, as we have developed day by day another processes, we start to tag the processes with the another word, that is the advanced manufacturing processes. When we say the advanced manufacturing processes, means as I have told you already during the explaining of manufacturing word, that when we talk about the addition of the value in, or when we incorporate this sense of value addition, that belongs to the advanced manufacturing processes. So based on that also, people have started to classify the manufacturing process. And then in recent time, we have found another criteria through which we more popularly nowadays we classify the manufacturing processes, and that criteria is the addition or the subtraction of the material, and this becomes the more popular when we have practices the rapid manufacturing rapid prototype manufacturing processes more. In that sense, if I say that subtraction means when you are turning the job on the simple center lathe, means we are removing the material and we are getting the part or the product or the job. So that we say that by removing the material means we are subtracting it. But if you talk about the process like the 3D printing process or other loam process, or so this kind of, in this kind of the processes, we add the material progressively and finally we are getting the product or the job. So in that sense, nowadays we classify the processes like additional manufacturing processes, subtraction kind of manufacturing processes, and third category is the modification or shape changing processes, where we have some initial, we are just getting the product by changing the shape, and that shape changing may be in the different phase of material also. It may be like semi-solid or it may be in a solid, sorry, and it may be in the liquid form. Now with this, I would like to just extend two more term, that is the hybrid process and the allied processes, because when we talk about the advanced manufacturing processes, it is a value or worth to us to understand these two words. So can anybody give me the hint, or anybody is knowing what do you mean by hybrid process? I think hybrid process people are very clear, but in allied, some of them maybe okay.
Actually, sir, allied processes, which the processes which are the like additive, subtractive, and elsewise, I suppose.
Okay, okay. So basically, hybrid process means the process in which we are we are using the two different working principle of the processes, or the fundamentals of the two different principle for overcoming the limitation of one over the another. So that kind of the process we call it the hybrid process. Okay. Whereas in case of allied process means the process where the working principle, fundamental principle will remain as it is, but according to the objective aim, or you can say the application, very wide changes we establish into the configuration or in working of the process itself. For example, if I say the electrochemical machining, okay, so there is the two kind of the source we use and the mechanism we use, that is the one electrical source we use, second is the chemical background we are using. Okay, so I say without electrical also you can do the machining by that only the chemical process, but that process speed is very low and it will take the low so much time. So people have started to add the second source of energy which help to accelerate that process, and that way they have added the second principle, right, to remove the material with the help of electrical energy. So that is what we say, that is the electrochemical, mechanical, and then whatever the extension is there, that whole group can be in the hybrid process. Now in case of allied process, I say electrochemical grinding, right? So electrochemical grinding, you have another two processes. of that electrochemical grinding, that is we call the allied process. Suppose electrochemical deburring, right? So electrochemical deburring is the allied process, because the principle what we use it is same electrochemical, but or whatever the principle we use in the electrochemical grinding, in one sentence we can say in that manner, but the configuration totally what we use or the set of configuration is totally different. Similar way, shape tube electrochemical process, right? Or shape tube electrochemical drilling process, you can say. So these are the allied process. Okay. So from this slide, I think we have understood the evolution of meaning of manufacturing, classification, and some advanced term related to the manufacturing domain. And this is the just, I am skipping this slide very quickly, but you can take this reference, and in this reference, now researchers have very nice manner, they have classified it completely the kingdom of all manufacturing processes with the different, the right side what you see, these are the criteria I say for these particular stage of the classification, right? So let us skip this slide, and we are coming on the second term, that is the modeling. Now modeling means what? Modeling, we take this meaning of this word in very different way. So in our, with respect to the our domain, I say modeling represent an object or system with its all or subset of the property, but it will not be the exactly the same as the actual system or the object is. Okay, there are the certain differences between the model and the actual system or the object. Okay, then this question is arise, why this we need. So here are some points I have noted on the slide. Like it can be we need for prediction purpose, for training purpose, for investigation purpose, or for testing purpose also. But there is a always limitation of every model. Okay, and that depends on how good way you are making that. That we will discuss in the coming slides. Now, after this, I would like to say, in context of our domain, that there are the different kinds of models, right? For example, we are preparing the physical model, we are preparing the analytical model, we are preparing the empirical models and phenomenal model also. Physical model, I can give you, I think no explanation is required. Analytical model, also people are knowing. Empirical is also knowing, but just I would like to say in one sentence, through the experimental or by gathering the actual data or the fact data through the physical activity, you are compiling, and later on, based on that, when you establish the relation among these known and unknowns, that kind of relation we say it's an empirical model. And the fourth one is, that is the phenomenal model. In phenomenal model means based on the phenomena we develop the model, and that I will show you the one example. Okay, so where even though certain certain aspects of the process or the system for which we are making the modeling, we are not considering. So based on the phenomena, the model which we develop, that we call as phenomenal model. Then next term which I would like to discuss, that is simulation. This is the third word which is in our title, that is the modeling and simulation. So basically, when we say normally the simulation, we say here the sentence is like this: for the create virtual sense, create a virtual scene and how a real physical situation would be under the circumstances. But I say, let us not restrict to this sentence, and let us extend our opinion in this. Sometime nowadays, people also say we have simulate a physical situation. Okay, so in our research work also we do that. Okay, so when I say simulation, so basically, of course, it is here related to the modeling concept context again, but simulation it is not always a virtual. It may be physical also, and I can argue this way also. Sometimes we make a more when we do the experiment. Okay, you make a setup. Okay, when we make a setup, and what is that? We are making the physically the model, right? And later on, you are putting your job or specimen and you are conducting the experiment. So what you do, you are trying to evaluate if such kind of the actual situation will be, then what can, how we can govern it. That things we try to learn from that. So again, what we do there, we are simulating that actual or future situation, right? So in that context, we are sometimes using this word simulation also. Okay, but here, whatever we are going to discuss, that is based more on the mathematical models. Okay, and mostly when we adopt this situation, in case of when the actual or the future task is very to create, or in a future whatever you are going to do, it is very difficult to handle without any background. In such kind of the situation, we simulate it first. Okay, or the situation is very complex, dynamic, such kind of the conditions are there, then better we have to simulate that, and later on we can handle it, right? So this is the correct way. But here also, as I say, in the modeling there are the assumptions, so its prediction also depends on that how good way you have simulated the situation or the condition. Fine. So after the understanding this basic 3 4 terminology, let us come on our this one question, that why modeling or the simulation is we have to done. See, actually, I inspired to talk about this topic. Some of maybe knowing me, I feel that over the period of time that wherever I'm going as an examiner or in some panel or as an expert, I found all most of the time out of 100, I found a 92 to 93% work what people are doing, that is the experimental or parametric study, and they say so regression and by minitab, that's all most of the work what we do here, right? So I feel why we are not digging ourselves and exploring in this area, or I feel that I should let me say as a motivate to our student, our researcher, that we should work in this area, because now this is the time what we talk about the IoT based system, we talk about the artificial intelligence, and whatever this kind of the advanced domain is there in this whole system. 50% in soft domain, it work based on the modeling and simulations. So if you want to perform, if you want to go further or grow better way, then I think all we should put our effort in particular modeling and simulation area also. Then and then we can survive and we will come up with the better solution for the future applications. So that's why I say I feel that I should talk about this. Okay, fine. So why modeling is required? After discussing this on the seventh slide, right? Can anybody just give me the one or two hint why modeling or simulation is required?
Because, sir, from simulation we will get certain results, which we can just say that suppose if we do certain stress analysis or certain type of stimulation in terms of mathematical modeling, that
Yeah.
mathematical equation will give us the relation. What is the relation
Yeah.
between output, response, and input?
Okay. Fine. So in sentence, I say this is the one of the I think clever sentence to understand why the modeling and simulation. To the best way to predict the future is to first create the future and let us play with that. Once you are able to play, once you are able to govern it, then you can handle the future better way. And where this modeling and simulation help us, right? So that's why I say all of us should put a effort in this direction. Okay. Now this through this slide also further one thing I would like to say, when we talk about the complete scientific methods investigation, definitely both should be there. Like what we say, the experimentation, and that is what we say the physical model. Second, simulation. It may be on the mathematical model or virtual model. That what is. Okay. We have to work in both the domain. Then and then the complete representation of real system is possible. Okay. So that's why I say let us come out from this blue box rectangular and let us work and jump and learn in this area, that is the simulation or the modeling. Okay. So after now completing this basics of this terminology, let us now start the discussion for modeling approach. And for that, I have taken the case that is from the advanced manufacturing process, that is the abrasive jet machining process. Of course, looking to the range of the audience, I have taken this example. Uh, so very first, let me give you the just initially the working principle of this abrasive jet machining process. Right now, just those who are very new, those who are at third semester or fourth semester, they just know in this sense, this manner, sorry, that in abrasive jet machining process, we are removing the material by creating the jet of abrasive particle and the air or gas, and that jet we are targeting the surface where the mixer stuck or tight, and later on there from there by erosion action material is removed. Okay, what is that? How, what mechanism is there? Mechanics is there? What many things are there? You need not to go right now in that detail. Intentionally, I say we need not to. Let us assume we do not know that. Then also I say I want to claim that you can do the modeling. Okay, so that is the best part of the modeling work. Even though sometimes you do not know the science or engineering of the process, you can model it. Okay, let us see this. And application, I say very one application pinpointed I written over here, that you can create a hole with the help of this process in a glass. You know, right? the glass is a fragile material. In such kind of the material, we can create the hole. So that's the very peculiarity of this process. And right lower side here, I have shown the basic players of this process like abrasives, carrier gas, abrasive jet, and nozzle, and their individual properties or the parameter definitely play the role when the process performed on particular kind of the workpiece. Okay, so this is the just general information of the parameters of the processes. Now I am coming on the, let us say we want to make a model for this process. So I say initially interest comes in my mind that let me create a model to find how much material can be removed for a particular this agent process in certain so and so condition or certain circumstances. So see, this is the very universal, I say, or generalized strategy, I say. Whenever you think for the modeling, I say it is a kind of the journey. Kind of the journey of what? I say it's a kind of the journey from known to unknown. From known to unknown. But our problem is that how we pick that. Okay. So initially we start our journey in the reverse direction, that we have to trace a route between unknown to known. And once you are establishing the route, sorry, between the unknowns to known, definitely you can make a model. Okay, so whenever you think to develop the model, you make a roadmap for that. I say it's a roadmap. And here, I would like to put that one of the example in that for this process, right? As example, that suppose we have started, we have taken the decision that we want to make a model for material removal. Okay, so I have to find out for generally the material removal is find we are measuring or finding in what sense. So people from the book literature, I say, oh, it's a mass per time. So I have written over here initially material removal rate is mass per time. So per time is means you can say immediately it's a unit time, right? Per unit time we have to find out. So my still challenge is that I have to find out then mass. Okay, fine. So how I can find the mass? This all, see, I am taking the concept, what all the principle what we are right now using, that is the school level or higher secondary level, what we have learned in 11th 12th maths and physics. That's it. We need not to right now understand the engineering aspect, sorry, engineering level mathematics or other things for this kind of the modeling. So what I'm doing, I'm saying that I have to find out the mass. So okay, I know the mass in this sense, or volume into density. Fine. So it means it says me that I should find the volume of that material. So how can I find the volume? So I say to remove the particular volume. Suppose let us say this is the this one is my job blue one, and this one is a particle, okay, abrasive particle which remove the material. And I later on I will explain this another way, but initially I say I want to show you the how material which is removed. So I say at present you just accept this material I am removing. Okay, so I have to find this volume. That is my now challenge. Okay, so it is very clear that whenever we want to remove or whenever we want to work, then in our science, with the base of science, we say that we have to do the work done. Okay, so how much work done I should do to remove this material? And when I'm doing the work, I am spending the energy. Okay, fine. So to find out the volume, I should know the work done. And once I know the work done, I can find the energy. Okay, so I should know the energy, and this energy from where I can find. So you can find with the help of the parameter, or I say whatever the controls you are using during the process. I mean to say in the abrasive jet machining processing. Okay, so this way you can establish your roadmap to develop the model. Once you are completing these steps, then you have to now complete, or you have to go and target one by one points, and at the last you will get this model what you are expecting. Okay, so you plan for modeling and simulation, I say you first make this way the roadmap of modeling. What I did this way. The simply you make a route or find out the road between the known and unknown. Okay, here known are what? The control parameters of the process. Unknown is what I am expecting, that is the material removal. So once I establish the route, told you I know only about the process, that I am throwing the abrasive mixture of abrasive and gas or air in the jet form on the work surface, right? On the work surface of abrasive and the gas. Fine. So basically, the material which remove, that is by the abrasive, right? That common sense will say, because it is only the habit at present. Because here there is other process where we are using this air or gas or liquid as a also a material removal tool, but here it is not that, because I'm not using it as a material removal tool. Remember this one. So here I say, here I'm putting this one abrasive, and I am very clever that because I know these, if I put the circle form, then I can handle the relation mathematically easily. So initially, I am putting this abrasive in this circle form, and that way I am complete establishing the relation between the abrasive and the workpiece. Okay, fine. Then later on, as I told you, we know that this much material we want to suppose. Let us say this much material is removed. Okay, fine. How it is removed, by which mechanism, I don't know. But I say when it's tight, this much material is removed. This bluntly I am just arguing. Okay, fine. This much is removing, so you have to find out the volume as per our plan. Okay, so for finding this volume, I should know the certain basic parameter of this. So I know the radius of or this diameter of abrasive, right? And that is what we say the dg, and AB equal to the radius of that. Fine. And you can see here the certain geometry is already drawn over here. And based on that, with the help of the very simple maths what we have learned in the school level, right? We can find the volume of this. Okay. For that, again, you have to find out first this its depth, and then you have to find this distance. Once you know that, you can find the volume. Okay. So what I did here, I have drawn this with the 90 right angle triangle. I apply the Pythagoras theorem, and through that I have found the CB value. Okay. And once I know this, I can find the volume. That is, volume is equal to pi by 2. Right now, how this comes, you can manipulate these mathematical relations, whatever parameter of this parameter, you will get this definitely. Okay, so we are right now not going to discuss that because our intention is to learn the approaches. Okay, so now second step is I know the value. Sorry, next step is I have to find out the work. Now, because I know the volume, so I have to find out the work, that how much work is required to remove this volume. So we know that work done is equal to the force into the distance. Okay, so that is the average resistance of force into the depth. What is there? So force also we know stress is equal to force divided by area, right? So from that we can find the force which is written over here in this form. Fine. So the ultimately from this we will get the work done. Okay. When we are putting this all together and we simplify it, we will get this relation. Okay. So for doing this much work, I have to spend energy. It is very simple, right? Which we have learned already. So for finding the energy, which energy basically is your? I say we throw, right? We throw the abrasive. It means in physics school level we studied it is the kinetic, right? So the kinetic energy is 1/2 mv square. So here also you can put this all. Here you can put this all the values, okay, and you will get a kinetic energy in form of the known parameter. Now, another one more further thought is needed, and that is when this material I'm saying for doing this work, I need energy, so I spend energy, and that's why I am able to do this work. It means somewhere this material has been removed because of this equivalence, right? And that's why now I'm keeping this work done equal to kinetic energy. Okay, whatever the energy is given, that whole converted into the work. And that manner, through this simplification, I will get this delta. Okay, that is the depth of this, what is shown in this figure. Fine. Once you know this depth, then you can find this material removal through making your formula, right? And this MRR formula is normally vary according to the, when you see differ the different model according to geometry, we have to fix up the relation. But generalized in this manner, you can say volume of material removed per abrasive and number of abrasive per second, whatever they are striking on the workpiece. Okay, and later on when you put this all the value, you are getting this relation. Okay, and this relation is nothing but, sorry, what is it is, it is a one kind of a simple model which through which we can predict the material removal rate, right? So first observation, as a miss, now we are enough mature, so I say, see, when I say I have done this modeling, means I say, yeah, I have, even though I do not know the basic science, basic engineering of this process itself, I'm not saying generalized science or generalized physics, right? Fundamental. I say the general specific science and engineering regarding to this process, I have modeled it, right, for prediction purpose. What material mode? Okay, but now from here, other story is starting. When you claim that I have modeled, definitely some good people will always come forward and they will support you with a very different statement. Okay, let me show you and how we can extend and grow from this stage. Let us see. After modeling this thing, one person say, hey, you have not considered the effect of gas. Okay, so actually, as in a few couple of minutes before couple of minutes, I told that we are using the abrasive and gas, right? And gas is not as a two material removal tool that I told. Okay, so thought they he gives you, and he's arguing that manners of way that you have not considered the combined effect. I say, okay, sir, I have not considered. Let me put that. Okay, so what I am doing now, I am doing the ratio of these two. Okay, abrasive mass flow rate and divide by combined mass flow rate. Combined is it means mass of abrasive plus gas, and that way I find out or I put or I frame a one ratio, that is the mass ratio. Okay, but ultimately the role which play to remove the material is abrasive. Okay, so now here is the now one thought which has been given by somebody us to us, and we have to think now how we can improve this my model. Okay, how we can improve or where I can take the effect of this gas also. It is very simple. Simple things I have taken first, so we can understand it easily, and we get a bit guts to now work for modeling. Okay, so is there any feedback where there is a difference? Okay, I may not be able to hear. Uh, so I say, am I audible?
Yes, sir.
Okay, fine. So here I say, here this is the game changer play. MA. We have considered only the mass of abrasive. Okay. So what I should do, if I want to incorporate the effect of this, then I should consider this ratio, and that ratio I can again bring into the form of this MA, and later on I can modify this model. Okay, so that manner you can I say improve your model, and there is always a scope of improvement. Remember, we need not to just feel that, oh, I have done so much effort and somebody is saying and now everything. No, it's not like that. Okay, because here next I'm giving you the it's key also. I'm giving you the uh, uh, some of the hint also that how we can overcome of this. Okay, okay, fine. So this is the one. Second is now one more smart guys come to you. Okay, and he says, "Arey bhai, what you are talking in this model, that abrasive you have shown like a ball, but when I went in the market, okay, I observed that the abrasive are not in that form. The form is like that, even I am not able to speak what is the shape of that. Okay, I say, fine, sir, you are right. Another guy say, hey, You have no way to talk about the material. You say only you have just drawn the one's rectangular shape and you say it's a workpiece or it's a job on that we are throwing the abrasive and you have developed a model. I say, yes, sir, I have done that way only. I'm not saying another thing. But yes, you are right, sir. The materials are also have a very wide range. Like for example, here the copper, and here, as I told, this is the one of the example, good example of application of a gem, that is the glass. Fine, sir. Now what I can do? I need not to feel any bad in that. I say, and God has blessed us with one very good word, and that word is assumptions. Now I can answer to these people in this manner, and that is the very right way also for framing our model day by day robust. Okay, so what I say, okay, sir, when you say this one, so I assume in my model the abrasive are spherical, equidirectional diameter, radius. Its shape is spherical. Now, is it okay, my model? I assume. Okay. With that assumption, I have worked and I have developed my model. Fine. Then somebody says, hey, when you stuck, when you throw abrasive on the workpiece, your abrasive may change its shape. Okay. Right. As per Newton's law. Okay. So I say, okay, sir. So I put another sentence. Sir, my abrasives are infinitely Z. Fine. So this way, right now, there are a lot many, even though right now I also do not know, but whatever we quickly frame, that I am putting over here in the assumption form or under the word of assumption, like kinetic energy, whatever we use, develop, that we use fully, volume of material remove is assumed to be equal to the indentation of volume to matrix. So this way, I don't want to complete this whole sentences, but this way, whatever things comes in your mind after developing the model, you put it without hesitation one by one. Okay, and present it that my model have this many assumption, and with this assumption, I have developed my model. Okay. And later on, if you want to extend that, you want to improve it, you can eliminate one by one assumption and incorporate that, as I have shown you by incorporating the effect of gas. Okay. So that way, one by one, and definitely it will not that much easy also, because to remove the one assumption from this list, you need at least more 6 to 1 year. Sorry, 6 months to 1 year, right? And as you move downward side, that time will be increased exponentially. Okay, so but I say this way we can practice ourselves for coming future. Okay, for this area. Now further, okay, sometimes we do that things which is not things which I am not able to do. I can leave for other also. Okay, so let me show very smart way. Okay, sir. After assumption, I found certain things, and that can be a future work, like a nature of material you can incorporate, as you told that in the material range is very wide, so we can incorporate it. Then the shape of abrasive, particular different shapes, yes, we can take into account its effect, we can take into account model. Okay, and that manner you can now when we represent this way, well, this is the what I say, this is in a 1 year I try to explain this thing in a manner that we are developed the model from the scratch, even though it is easily available on the most of the literature. Okay, but what I want to say now, Now, once this your whole exercise of model developing is over, now there is a question of presentation. So in the presentation or in writing, when you are writing it, you have to put this section what we did at last first. Okay, so first you put your assumptions with, and then you present your model. Here I have not done that intentionally because I want to make you more easier journey. Okay, so this way I think we can develop the model. Now here the approach I have said, the approach, what approach is, how much time is remaining? I think almost time is going to over.
Sir,
So
it's
here the
almost there.
approach is what? Approach is very simple, that based on I say without knowing much science or engineering of the process, based on the basic maths which I have learned in at the school level, I have developed the model. This is my one of the very clear observation in this. Okay, but as you try to eliminate these one by one, definitely you have to refer that. Okay, so after completing this one approach right here, I would like to quote another case, that is the simulation of profiling in abrasive jet machining process. Okay. So in this now very quickly, because we are running a sort of time, I think 10 to 15 minutes only I have now. 10 minutes, not more than that. So, okay. So now here, what here I would like to highlight another approach. That's all. You, if you want to go in a detail, you refer this literature. So here the researchers have developed the virtual tool to see the progress of cut profile in the workpiece. Profile means what I say here. Just 1 minute. This one, this hemispherical shape, how it grow with the time. That we did. That they did. Okay, fine. So here also, I will summarize that all. And this is the literature of 2009. Sapphire and his team has worked on that. And this is the simulation, is the time dependent simulation. Eroded mechanism they have considered for the analysis purpose and for making this simulation model. They have considered this special effect of particle interfacing. Okay, when we in our model we have just considered the one abrasive. Okay, and later on I said okay, now I multiply it by the number of abrasive which are strike on the workpiece. Okay, but that is not the actual case. Okay, some of the particle when travel from exit of nozzle to the work up to the work surface, they may stuck with or they may collide with each other also. There are a lot many other things going will be happen in that particular route, and that all things we have neglected. Okay, whereas from that many all kind of the event, he has picked up one only. Remember that, see again say it is he have picked up only one, and that is the particle interface. Okay, now for that purpose, as I told, as we have learned in the previous slide, it's a journey of known to unknown. So known things which he has considered are nozzle size, standoff distance, inclination, velocity, particle distribution. And after this, I would like to put this slide, and let me show you something hanged. Yes, it's not. Okay, fine. Fine. So the strategy, what I said, the roadmap. Remember again, he has made the use that strategy. This I have framed from the literature. Okay, from his published paper. So I feel that what he want to know particles spectral and velocity distribution, interparticle or particle to surface collision. So for that, again, he want to go for criteria for material removal, and once he has fixed up the criteria for that particular criteria, he has developed the algorithms. Okay, and again in that algorithm I have technically written over here in our sense that what way he has developed the algorithm and the language what he has used, that is the Java, and ultimately in that way he has developed the simulation model, and later on he has validated. And here also you see the assumptions what he has done. Lot many assumptions he has done. Suppose geometrical assumptions he has done, then distribution based point of view is done. Now you see what I would like to highlight. He has his more work is started in this only area. Now you see, you can adopt this approach for simulation and modeling. That's why I'm highlighting this one. I'm not going to explain how this equation comes and that equation comes. What he did somewhere in 2008, sorry, not 2008, he has found this is the probability of particle arriving in this jetting action. So from that, he has picked up this total relation. After that, later on, he has established that relation in its required from with the geometry what he has drawn for the particular jet. Okay, and later on again for what I say the criteria for fixing the criteria for material removal, he has taken the another past research work from, see his range is from in 1960, so he has referred from 1960 to 2008 up to 8, and he has published this work in 2009. So from that he has picked up this one, that is the erosion rate can be like this. Okay, once he know this erosion rate, and later on these basic formulas or relation has been used by these people, lot many other people, and from that he compiled that ultimately the basic relation established between the erosion rate and my setup can be in this form. Okay, my setup means his setup. Okay, so he has established this one, and then again he has manipulated that mathematically, and later on he has found this relation by giving the some modification. Now what is this? This is ANSI is nothing but number of cells. So approach what he is used now, what he says that yes, earlier we told that one abrasives fall on the surface and it remove the material in one chunk. Okay, now he said no, it's not like that. Suppose this much material is there, then it will goes in this layer form in the 2 dimension like this first, that it has a height h. And if you talk about the 3 dimensional, then I say it may be in the form of cube, and that cube height is h. Okay, why he's doing this? Because in computer language, it is easier way to write in the program in this manner. Okay. So after that, what he put, that is the number of cells which remove. For that he has established this relation, and he said when this cell value is 1, it means the material is removed, and that is the criteria for surface. Okay, so after establishing this relation, okay, he had again used the to what value I can use for this, because the material is changing. So he has found from the other literature that for brittle material relation is this one, and for ductile material relation is this one. Means his work almost 80% is over. Now for his task, or for completing his particular individual task, he has to write only the program, because he have now all the relations. Okay, so later on he has developed the algorithm. Okay, and that also he has referred from the different literatures which I have highlighted over here, and later on he has validated it. Okay, he has validated it with the experiment. Okay, so now here what observation is there? What observation is there? I feel that, see, you can develop the simulation model by considering or taking into account more the past work which has been done. Once you have to line up it, you can do it. Okay, what he did basically, almost the relations he pick up from the past literature, and later on he has contributed more for making the programs. Okay, so with this I think time is almost over. I have many other examples. Case studies already, my main still 4 to 5 case studies are still with me, but still I think time is over. So let us stop over here with the 2 case studies and how to make a model and simulation. And let me put my remarks now. So I will skip this all the slide directly, and I am coming on my remarks slide. Okay, so here you can see that experiments normally physical model and simulations normally mathematical. This I can say. Then another remarks with which you can put that for modeling and simulation, for goal different routes, approaches are possible, and no model, no simulation is complete. Okay, or model and simulation never be a complete model or simulation, right? And simulation is preferable over modeling to overcome physical challenges or dynamism, right? There we use more simulation, and based on complexities should be involved as per need. If you, for particular your task, if the complexity is not required, certain, suppose my this MRR model which we have developed for HM is work within the 5% accuracy or 2% accuracy, and my tolerance is that much, then why I should consider the shape of the abrasive particle? Why not spherical, right? So this you can do. So in that context, this fourth remark is there, that consider only that much complexity which you need for achieving or attending your task or goal. Then the future scope, I say, the future prediction nowadays is necessary, as I told you, because we are now living in an era of IoT developing era, and AI is enough mature now. Its stage is at a mature level. Okay, so for that purpose, definitely we need modeling and simulation. And at last, no model and simulation is complete. So once again, I would like to thank. These are the references which I have used for this talk, and I think I will present right now the 30% only. 70% still with me. If I get second opportunity sometime, we will discuss some higher level of modeling also, modeling and simulation. So thank you very much to all of you for keeping patience. Okay, and it is
Uh,
over to the Professor Abhi sir and Professor Trivedi sir.
yes, sir. Yes, sir. There is one question which has been asked from student.
Hello,
Sir, question. Yes, sir.
I'm
Hello.
not able to get full. Yes.
Yes, sir. Sir, question is, what are some possible new concept of advanced manufacturing that might apply to a wide range of industries?
Hello, advanced manufacturing.
Techniques, sir, which we can apply in industries. Sir, also I have written in chat box.
Okay. Yes. Uh, am I audible?
Yes, sir.
Yes, sir, well audible. Yes, sir, you are well audible, sir.
Taylor, sir. Hello. 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 Taylor, sir. Okay. Thank you, Taylor sir, for giving such a nice presentation, knowledgeable presentation. Actually, it was a great, knowledgeable presentation, which we have got a very high knowledge, which I also don't get at my study, BTech and MTech. So it was very nice meeting to you, sir. Thank you, sir. We will call you back again in the next session too. Thanks, sir.